Okay, question on number 8, which on worksheet 2.4a, where you are asked to show if f of x equals 1 for some x on the interval -2 to 2, inclusive for the function given. So I'm going to attempt to clarify here. This is a problem that will involve the intermediate value theorem. So I'm going to think visually as I go through this. First thing I'm going to ask myself is, in order to use the intermediate value theorem, I need to know that my function is continuous. So I actually usually write on my paper is f of x continuous on the interval from -2 to 2. I'm just going to put my answer this time, and I'm going to say yes, f of x is continuous. It's a cubic function, and cubic functions are continuous on the interval -infinity to +infinity, which clearly includes the -2 to +2. So we've got that done. So now I'm going to check my endpoints, my -2 and my +2, and I'm going to evaluate the function at both of those points. So I'm going to figure out f of -2, and then I'm going to figure out f of +2. And I went ahead and did the math, so I'm going to just give the answer, and then you can go back and check it as long as my math is correct. I was not using a calculator, so hopefully I did my mental math correct. I'm getting -7 and +9. And I really am at this point thinking visually, and I'm making the conclusion that I've got a number less than, I put 0 because I'm used to doing roots, and this question is slightly different. It's asking about how does it compare to +1. So a lot of the questions we've done, like I said, have looked at, is there a root between two numbers, and that's where I'm looking at, does f of x equal 0? I can make that number anything I want. So in this case, I'm comparing it to 1, and I'm saying -7 is less than 1, and +9 is greater than 1. And that's exactly what I want to have happen in order to be able to make a conclusion for my intermediate value theorem. Big idea is, here's my graph, and I've got 2 points so far. I've got at -2, then I've got all the way down here at -7. I've got a point, and then I've got +2. I've got a point all the way up here at 9. And if my function is continuous, which we've established, then I know that as long as I'm going to get from down here to up here, I'm going to have to pass through. And my magic line here that I'm looking at is really right here, y equals 1. So that's where I'm looking, do I have to pass through? And no matter what kind of a line I draw through there, I'm going to be doing something where I am indeed going to pass through there. Okay, so now I just need to write my conclusion and say, yes, I am going to have a value, some x value, in the interval -2 to +2 such that f of x is equal to 1. So my conclusion is going to look like this. My conclusion is going to be since f of -2 is less than 1, which is less than f of 2. Another way of saying that is 1, my value that I'm looking for, is between, this value is between these two values. That's what I've showed right here. Since I have that true, and I should mention in here that f of x is continuous on the interval -2 to 2. Make that a closed interval. The intermediate value theorem guarantees, or we can guarantee by the intermediate value theorem, that there is an x which is between, or you can put a c as the letter we used in class, which is between -2 and +2, or there is an x in the interval -2 to +2, would be another way of phrasing that, such that f of x is equal to positive 1. And the final part of this question, which isn't in every intermediate value theorem question, but what I did ask is, graph the function to see if your answer is accurate. Does the graph match your conclusion exactly? And what I wanted you to notice is, and I don't have this graphed in front of me, but I'm going to actually do it really quick because it's been a little bit since I looked at this graph and I can't recall exactly what happens. Okay, so I'm looking at the graph right now, and what I'm noticing is happening is, I'm going to use a different color here. I'm going to use red on my graph to show you what's happening. The graph is actually going up, coming back down, and then going back up. And that's not a great picture of it. But what I want you to see is that the graph, what I've done in red there, is passing that yellow line 3 times. So it's passing it through it right here, right here, and right here. It's actually 3 times within the interval -2 to +2. Our conclusion doesn't say that. Our conclusion that we've put right here only says that it will pass through at least 1 time. The intermediate value theorem is limited in that it doesn't tell us how many times. It just tells us if there exists a time where we will get a certain functional value. And that's what we've done. So the graph is more accurate, but we have been able to determine that there's at least 1 time. And that's the limitation of our intermediate value theorem. Okay, hopefully that helps with number 8 and how you work through an intermediate value theorem problem.